we have been solving problems on linear differential equations of higher order with constant coefficients. So in the previous videos, we learned how to find a complementary factor and also 3 different types of particular integrals. And as you all know, the solution of any higher order differential equation is y is equal to the complementary factor plus the particular integral, that is y is equal to Cf plus Pr. And to get full marks in this module, okay, you need to know both the Cf and the 3 different types of particular integral. So understanding those is compulsory. It's compulsory. Therefore, I request you, if you haven't watched my previous video, then please find a link in the description below or refer the playlist. Please do it. Okay. So as I also told you, in the VTU examination, they will be giving mixed type of questions like this. That is, they will include all type 1, type 2, type 3 or any one or two of this. Okay. So we will be solving today those mixed type of questions here, and I assure you that if you are able to solve this question, then you can solve any question in the VTU examination with ease. And believe me, the questions asked in the VTU examinations are very, very simple. So let's start solving this problem and make mathematics more simple. Fine. So the first problem is, solve d square minus 60 plus 9 into y is equal to 6 e raised to 3x plus 7 e raised to minus 2x minus log 2. Okay. So before solving this problem, let me have a simple recap. So I will be doing it in between or solving the other problems also. Fine. This is very much required. So please lend your ears to me and listen to me carefully. We solved all the 3 different types of particular integrals. The first was yp is equal to e raised to ax upon f of d. Here we replace only d in the denominator by or d is by a. The second type was something different, trigonometry. Sin x or cos x upon f of d. Here we replace only d square by minus a square, we do not touch the t's. And the type 3 was, which is solved in the last video, was yp is polynomial upon f of d or algebraic expression of f of d. The solution is nothing but the quotient of the 5x upon f of d, the numerator in descending order and the denominator in ascending order. We use a long division method to solve this problem easily. Okay. So we will be encountering all those methods here while solving these problems. So the first problem is here. Again I repeat, d square minus 60 plus 9 into y is equal to 6 e raised to 3x plus 7 e raised to minus 2x minus log 2. So let's solve this. So again, as you know, y is equal to Cf plus Pr, we first find the complementary factor. Fine. So we have for this, what we do, we write the auxiliary equation, that is m square minus 6m plus 9 equals 0. Fine. This is very easy. It will be nothing but m minus 3, or you can use the calculator, but not required here. So m is equal to 3 comma 3. We have two same roots. So the complementary factor will be, see, the roots are repeated here. For repeated, c1 plus c2x whole into e raised to 3x. So let's underline this for the examiner. Okay. So we have the CFS c1 plus c2x plus into whole e raised to 3x for repeated roots. Fine. Now the next is to find the particular integral yp. So what is yp here? Yp is equal to this right hand side, 6 e raised to 3x plus 7 e raised to minus 2x minus log of 2 whole divided by d square minus 6d plus 9. Okay. Now, as I have been repeating here, wherever you get the right hand side plus or minus, each term given plus or minus separates each function, they may represent different type. So always separate them. When you have right side here plus or minus sign, always separate, because see, a plus b plus c upon d is written as a by d plus b by d plus c by d. Okay, this is the basic things of applied mathematics, you need to remember. So always separate. So now if I separate it, I get yp is equal to 6 e raised to 3x whole divided by d square minus 60 plus 9 plus, again see, plus is there, 7 e raised to minus 2x divided by d square minus 60 plus 9, and lastly minus log 2 divided by d square minus 60 plus 9. Am I right? Fine. Now we need to understand what types each term represents. So as I discussed, what is type number 1? E raised to x upon f of d. If the right side, if the function, if the numerator is exponential, it's always type number 1. What's type number 1? E raised to x. This is how to identify. Again listen, how to identify the type? The numerator should be exponential, e raised to x type. Now see here, e raised to x, this is type number 1. This is what? Type 1. Fine. I write here. I write, this is type number 1. Okay. Then again see the second. E raised to minus 2x. Again is type number 1. Anything of the type of exponential e raised to x is type number 1 upon f of t. So again this is type number 1. Again log 2. See, log 2 is a constant as we discussed in the type number 1 particular integral. Anything constant is also treated as type number 1. Why? Because I can write this constant as into e raised to 0x, ax, 0x. Because log 2 is constant, correct, don't get confused. Log 2 is a constant. 1, 2, 3, 4, 5, 6, log 2, e raised to 2, e raised to 3, they may confuse you, that's also constant. Okay, so e raised to 0x. Now, since it is this is type number 1, now all are type number 1 here, all are what? Type 1, this is also type 1, this is also type 1. So all these 3 terms are type number 1. Therefore, what we do in type number 1? In type number 1, if the right hand side is e raised to x, that is why please go to numerator is e raised to x upon f of d. In the denominator, we replace all the d's by a. Which a? This a. Here is 3, here is minus 2, here is x 0. Okay, so now here we replace here d by 3, here d by minus 2, and here d by what? 0. That's it. Okay. So let's replace here now. So we get 6 e raised to 3x divided by, in place of d, so I will solve each and every step correctly here so that you don't get confused at any step here. Fine. So please watch carefully, practice with me, and 100% you will become perfect. If you don't do that, I won't guarantee. That's it. Okay, all these videos I am making all efforts only for your benefit. Fine. So you need to listen what I say. So 6 e raised to 3x upon, see this is 3 square minus 6 into 3 plus 9. Correct? It plus order d by a plus 7 e raised to minus 2x whole divided by, again what is d here? Minus 2. See, in place of d put minus 2. So minus 2 square minus 6 into minus 2 plus 9. I write it clearly here. Okay, minus 6. Okay, and lastly minus log 2 divided by, replace d by 0, 0 minus 0 plus 9. Done? Fine. So this is a very simple question. They asked 7 marks. So let's write here, that is 6 e raised to 3x whole divided by, see 9 minus 18, it is what? 9 minus 18 plus 9. 9, 3 square is 9, 6 is 18 plus 9, and this will be 7 e raised to minus 2x divided by 4 plus 12, am I right? Minus 2 square is plus 4. So minus 6 into minus 2 is how much? D replace d by minus 2. So minus 6 into minus 2 is plus 12 and plus 9. And lastly plus log of 2 divided by 0 minus 0 plus 9. Done. Let's again simplify. Now if you simplify this, see what happens here. See, 9 percent 18 minus 18 becomes what? 0. Now again recall, we have solved many questions of type number 1. If in type number 1 we replace denominator all the d by 0, and if after replacing, if the denominator becomes 0, then what we do? Multiply the numerator by x and differentiate the denominator. What is that? D square is 2d, differentiate d square is 2d minus differentiate 60 is 6. That's it. correct? Differentiate d square is 2d and differential minus 6 is minus 6. 6 into d, d is 1. That's it. Again replace d by what? 3. And I think this is done. 7 e raised to minus 2x divided by 4 plus 2 16, 25 minus log of 2 by 9. So again, see again, when I replace here, again see this will be 6x e raised to 3x upon 2, again replace d by 3. 2 3s are 6 minus 6 plus this as it is already solved, because solving any differential equation means removing all the d's wherever. Again 6 minus 6. 6 minus 6 is what? 2 3s are 6 minus 6 is what? 0. Again the denominator 0 means what you do? Again multiply the numerator by x. 6x square e raised to c. First case, again don't ask me where the x square came from. Theory. After replacing d by a3, when we are getting 0 here, 18 minus 18 0, multiply when denominator becomes 0, multiply numerator by x and differentiate the denominator. Again replace d by 3. Replace d put 3. 2 3 is 6 plus 6 0. Again when denominators become 0, the cycle repeats. Again multiply numerator by x, 6x square upon e raised to 3 is upon. What is difference to 2 again? Simply 2. That's it. So plus 7 e raised to minus 2x upon 25 minus log of 2 by 9. Therefore, the particular integral is equal to what? Yp is equal to 2 1s are 2 3s are. Fine. 3x square e raised to 3x plus 7 e raised to minus 2x by 25 minus log 2 by 9. Now as you all know, the solution of any differential equation is nothing but y is equal to complementary factor plus the particular integral. Okay, I write here, so y is equal to cf plus pi. Therefore, we complete the full solution as y is equal to what is cf here? Cf is c1 plus c2x whole into e raised to 3x plus 3x square e raised to 3x plus 7 e raised to minus 2x by 25 minus log 2 by 9. Beautiful solution. So, you have to represent the solution like this to get the entire 7 marks. That is how it is done. We have one more interesting problem here. It says d square by dx square minus 6 dy by dx plus 25y is equal to e raised to 2x plus sin x plus x. All the 3 types are there. Okay. So, let us solve this now in an easy way. So, first what we do is we write d square by dx square as what? D square minus 6d plus 25 into y equals e raised to 2x plus sine of x plus x. So, first thing first, we find the auxiliary equations. X square minus 6m plus 25 equals 0. Okay. Now, let us find a root here. For that, I will use the calculator. So, I am using here fx 991 cw. So, let us find here, we go to on, home, then we go to the equations, and since we are finding the polynomial ax square plus bx plus c is equal to 0. So, we have the coefficient of m1 minus 6 and 25, 1 execute minus 6 execute and 25. We get the roots here as x1 is 3 plus 4i and x2 is 3 minus 4i. So, m is equal to 3 plus or minus 4i. It is a real and conjugate root. Okay. So, imaginary root. Therefore, refer my CF theory. We have the complementary factor as c1 cos raised to, say always the imaginary terms comes for cos and sine. Okay. Please refer the video on complementary factor if you find any doubt, plus c2 sine of 4x whole into e raised to the real term is 3x. And let us underline this for the examiner. I repeat. Okay. Do not lose any marks. Fine. Fine. So, we got a CF here. So as we are done with the complementary factor, let's move on solving the next important part, that is the particular integrals. I hope you are getting the concepts clear here. Okay, and I truly hope you are enjoying solving these problems with me and understanding the concepts clearly. See, reading through your comments and knowing these videos are helping so many of you makes me genuinely very happy. See, my mission is very simple. I want each and every engineering student to understand the concept of engineering mathematics clearly and confidently and pass the VTU examination successfully, whether you are a regular students or you are having maths as arrear. So please don't keep it to yourself. Share these videos with your friends, your classmates as much as possible, or anyone who needs an extra support to pass the VTU examination. And also in the end, please don't forget to subscribe. So let's move on solving the particular integral here. So we have yp as you know, yp is equal to, see, e raised to 2x plus sin x plus x whole divided by d square, that is right hand side, yp is right hand side, whole divided by minus 6d plus 25, right. Now as I told you, when the numerator has plus or minus sign, always separate. Is very important, crucial, because every function when there is a plus or minus sign in mathematics, applied mathematics, it means it is different functions, separate. So I don't know which type they belong to, so that's why separated. So we write yp is equal to, now here see, e raised to 2x whole divided by d square minus 6d plus 25 and plus sin x whole divided by d square minus 6d plus 25 and lastly plus x whole divided by, write it in a very systematic way and practice along with me. Okay. Now if you see it clearly, see here e raised to x upon f of t. See, all three types are there. Very interesting question. E raised to x upon d square minus 6t plus 25 means if the numerator is of the form of e raised to x is type number 1, correct. So we have this as type number 1. I write here, this is type 1. Okay, just for you to understand writing, it's not required writing the examination. Okay. Next, the second term is plus sin x upon d square minus 60 plus 25. The numerator is sine or cos x upon f of d. It is what? Type number 2. Trigonometry upon trigonometric function upon f of d is type number 2. This is my type 2. And lastly, x upon d square minus 60 plus 25. If the numerator is algebra or polynomial in the form of x is type number 3. That's it. So what? Type number 3. Fine. So let's solve each. So what I'll do, see, I can, if I want, I can solve everything here only, but what I'll do, I will take this as 1, 2, 3 and solve it separately and later add the particular integral. That will be very easy for you also. Okay. Now let's do it here. So I'll take this as say 1 and this as say 2 and this as say 3. Okay. So I'll write here. So first 1. Okay. For this 1. So again, type number 1. All three types are there in this question. So very interesting question this is answer solution is going to be. So watch it carefully and listen to me, lend your ears. Okay, resonate along with how I teach. The things will go here, enter perfectly and you will not forget. And please watch the video repeatedly. Correct. That's the beauty of human mind. Now we have first is what? y1, yp1, I'll take yp1 is equal to e raised to 2x upon d square minus 6d plus 25, and as you know, this is what? Type number 1. In type number 1 we replace denominator all the d's by a. What is a here? A here is 2, e raised to 2x. 2. Fine. So a here is 2, therefore this becomes e raised to 2x whole divided by 2 square So, I am writing each and everything here perfectly, because I know many of you students still lack in basics. Okay. So, again I do not want to miss any step here. So, e raised to 2x whole divided by 4, 2 square is 4 minus 6 2s are 12 plus 25. That implies we have this as, so I will take this as y p1. Okay. So, we have, or it not necessary, just to make it clear I am writing it y p1 as, what is that, 4 minus 12 is minus 8, 25 minus 8 is how much, 17. So, I got the first particular integral here, e is to 2x divided by how much, 17, that is it. Okay. So, this is my first one, fine, this is my first one here, that is e raised to 2x by 17. Now, let us move to the second one. So, I write here second one. Okay. So, second one is, I will take this as yp2. yp2 is equal to sin x whole divided by d square minus 6d plus 25. And as you already know, in the type 2 is numerator is trigonometry sin x or cos x upon f of d. Here we only replace d square by minus a square, do not touch the d's. Listen, we replace, again I repeat, only d square by minus a square, we do not touch the d's. So, what is d square? What is a here? See here carefully, sin 1x. So, a is 1 here, sin 1x. If it was sin 2x, then 2. So, sin 1x, so replace d square by minus a square. So, what we are doing? We are replacing d square by what? Minus 1, that is it. Okay. So, this will be now sin x whole divided by minus 1. See, do not again put, see many people do the mistake here, apart from so much of explanation, people do this mistake here. There are this minus 1 square. See, replace d square, wherever there is d square, put minus 1, that is it, simple. Simple English language. Wherever there is d square, simply put minus 1, nothing else. Minus 1 minus 6d plus 25. Now, this will be again sin of x whole divided by, so 25 minus 1 is what? 24 minus 6d. What is that? 25 minus 1, 24 minus 60. So, again recall, in type number 2 we replace only d square by minus a square, we do not touch the d's, only d square, put in place of d square, put minus 1, 25 minus 1, 24 minus 60. And if the denominator has a d term, then interior, but d plus something, then we rationalize to make the denominator d square, because it is compulsory requirement of type 2 that denominator should have a d square term. That's it. Okay. Now, let us do it. So, rationalize. So, 24 minus 6d. So, rationalizing factor of 24 minus 60 is 24 plus 60 upon 24 plus 60. So, this will be now open the bracket. We have 24 sin x plus 6d sin x whole divided by, say this is 24 square, a minus b, a plus b, minus 60 square. Okay. So, that will be again now. So, see again 24 sin x plus into d means what? Differentiate. So, again here replace d square by what? Minus 1. Okay, I forgot it. So, again when I rationalize, I get d square term here, see d square 6d square. So, better I will write next step, okay, next step for you, fine. So, do not get confused. So, 24 sin x plus 60. So, what is 6 into d? Into d means again differentiation, where into d comes differentiation. So, what difference sin x? 6 cos x whole divided by 24 square. So, what is 24 square? I do it here, better use the calculator. Okay. Fine. So, 24 square, right? It is 576. So, 24 square is how much? 576 minus 36 d square. Okay. 6 square is 36 d square. So, again replace d square by what? Minus 1. because type 2. So again if I replace by minus 1, we get 24 sin x plus 6 cos x whole divided by, see, 576 plus 36. Correct now? 576 plus, because when you replace d square minus 1 plus d square minus 1, 36 into minus 1 is what? Plus 36. Now again we have this as 24 sin x plus 6 cos x divided by, so what is 576 plus 36? So plus 36 gives 612. So 612. Now if you want to further simplify it, you can simplify it. You can see what is 24 by 612. Okay, 24 divided by 612 is 2 by 51. So 2 by 51 sin x, 2 by here 2 by 51 sin x, and what is 6 by 612? 6 divided by 612, 1 by 102, that is cos x by 102. That's it. Now what I got here is the particular integral for the second. Now the last one is, we have number 3, that is x divided by, so we have it as y p3 is equal to x divided by d square minus 6d plus 25. Now that is clear, that is type number 3. And what's the solution for type number 3? Refer my previous video, you'll understand everything perfectly. If the numerator is polynomial algebra, then the solution is quotient of, okay, quotient of the numerator in ascending, so there is only x here, leave it as it is, denominator in descending order, sorry, the numerator in descending order big to small, x cube, x square, so on, there is only x, leave it, but the denominator small to big ascending order, constant d, d square, d cube, so on. So here is 25 and minus 6d plus d square. So what I simply do is, we divide here. Okay, so let's divide this here and see what happens. So I will divide it here, there is no space. Okay, so I will divide it here now. So let's say x divided by, it is 25 minus 6d plus d square. So what's the concept? First term by first term, because I want to remove this x here. So simple logic, first always the concept is simple, this is called long division, first term by first term. So x by 25, it is 25 x only. Now 6d into x by 25, multiply it, minus 6d into x by 25. So this will be, I do it here better for you to understand. Okay, let's take some space here. So minus 6d into x by 25 will be minus 6 by 25. Why? Because d means x, d means what? Differentiation. Differentiation of x is 1. So 6 by 25 as it is, d of x is 1. Because d means what? Again differentiation. In differential equations, d means differentiation. So we have minus 6 by 25, again minus and plus. See, this cancels, x and x cancels here, that is the main aim. Again 6 by 25. Again to remove 6 by 25, what do you do? Again first term by first term, 6 by 25 divided by 25, that is 6 by 25 to 25 is what? Plus 6 by 625. Am I right? 25, 25, 625. So 25, again 6 by 25 cancels. Again see what happens here. Again if I multiply, no, 6d into 6 by 625 is 0, because differential constant is 0. So we cannot go further than that. Therefore this is what again cancels, and the answer is 0. Done. So whatever we get here, the quotient is the particular integral in the type 3. So I write here therefore yp3. So I was able to solve this entire question in the full screen here. That's great. X by 25 plus 6 by 625. Done. Therefore, as you know, the solution of the differential equation is what? The complementary factor plus the particular integral. That's why the solution for this question is beautiful. Y is equal to, let's write here, C1 cos 4x plus C2 sin of 4x whole into e raised to 3x. Write it clearly and legibly so that the examiner can see this and this and give the full marks. Don't confuse the examiner, please. Okay, and plus e raised to 2x plus 17. Then we have for the C, the solution was 1, 2 and 3. One was e raised to 2x plus 17. The second term was 2 by 51 sin x plus cos x by 102 plus lastly x by 25 plus 6 by 625. That's the solution. This is what we get. And the solution for this question, which will carry 7 marks. So if you understand and practice such question, same question repeated 2-3 times, no, then I guarantee that you will be able to solve any questions like this. They may change the d part, the left hand, the equation of d part, CF is okay. Right side also they may change, they may give e raised to 3x plus say cos 2x they will give, plus they may give x square. So you can refer the textbook and practice it yourself different types of problems. I wanted to end today's session, but I want my students to be more and more perfect. So let's solve one more problem here which has been asked in the VTU examination paper. Okay, so we have d square minus 4, again an easy question. So we write the auxiliary equations, m square minus 4 is equal to 0. So m square is equal to 4 means m is equal to plus or minus 2, correct. So m square is 4 means 2. So we have that is 2 and minus 2. Therefore, the complementary factor is very simple here. Both are different roots. Okay, so C1 e raised to 2x plus C2 e raised to minus 2x is the complementary factor here. Right. Now, let's aim at finding the, what we call it as the particular integral. So we have yp is equal to cos 2x plus e raised to 3x whole divided by, what is it, d square minus 4, and again I repeat, if the numerator is plus or minus always separate, it will have its own different particular integrals type. So cos 2x divided by d square minus 4 plus e raised to 3x divided by d square minus 4. So again the numerator is, first term is cos by something. So cos or sin upon f of d is type number 2, wherein we replace only d square by minus a square. So this is type 2. So write here type 2 for your understanding. And second one is e raised to 3x upon. So anything e raised to x upon f of d is type number 1, where we replace denominator all d is by e, type number 1. Okay, so I'll do it here itself because it's a small solution. So in type number 2, what's a here? See, cos 2x, a is what? 2. So we replace only d square by minus 4 minus a square minus 2 square minus 2 square minus 4. Again don't write ds2, only d square by minus a square. Okay, understand, minus a square. It is what? Replace d square by minus a square minus 2 square is minus 4. Very important. Okay, again this is type number 1. What's a here? A is 2 here. That means we replace d by what? A is 3. That's it. Therefore, we have here as cos 2x divided by minus 4 minus 4, correct? In place of d square, wherever there is d square, put what? Minus 4. Put what? Minus 4. Okay. So cos 2x divided by minus 4 minus 4 plus, again this will be e raised to 3x divided by 3 square minus 4. That will be, we have yt as equal to cos 2x divided by minus 8 and plus e raised to 3x whole upon 3 square is 9 minus 4. Therefore, the particular integral yt is very simple question it was. Okay, it is minus cos 2x by 8 and plus e raised to 3x by 9 minus 4 is 5. Therefore, the solution is complementary factor plus the particular integral c1 e raised to 2x plus c2 e raised to minus 2x, and as I always repeat, VTU, nowadays the syllabus they made very easy for VTU, especially new schemes. They will ask very easy questions like this. So please practice all the 3 questions. Okay. So again see, we have y is equal to c1 e raised to 2x plus c2 e raised to minus 2x, and what is the yt? Minus cos 2x by 8 plus e raised to 3x by 5. That's it. This is my solution. Done. Okay. So my dear friends, that's all for today's session. I hope you clearly understood how to solve the mixed type of problems here, that is which has order type 1, type 2 and type 3. And I solved these 3 problems here. See, the VTU syllabus, although they are made very easy, and I have been observing from all past years that in the question paper the questions they ask are very simple like this. So if you practice these 3 problems or watch the video repeatedly and practice along with me, you will become totally perfect in this. So I request you to watch the video and see by yourself, refer different textbooks, and without seeing the solution over there, the method which I have shown, you can practice the problems, and I am 100% sure, I guarantee that you will definitely be able to solve these problems with correct answers. Fine. So if you have any comments then or any problems you want me to solve, then please drop in the comment below. Till then, keep practicing, be confident. See you in the next video. Bye.